Good evening all. Am I audible? Good evening all. Am I audible? Can you hear me? In Friday class, I provided the community link and I already told how to post the assignment. Don't you get the links? In Friday's class, I have provided the community link and told how to post the assignment, but I think only there are around 10 people join the community and 2 of them only post the assignment. One is Vyomika and another one is Hariharan, I think. What about the remaining ones? Yeah, I will provide you the link again. Yeah, a few minutes. Wait for a few seconds, I will provide you the community link. In the chat box, I have given Facebook group link and LinkedIn group link. You can join either in Facebook group or LinkedIn group. Just join the group and do the assignment and took screenshot of the program and post it in the group. That's all. So the assignment is you have to write a code for PIR sensor interface with ESP8266 using interrupts and timers. You have to write the code, you have to verify the code and took the screenshot of the code and post it in the group. Is it clear? Everyone please do the assignments and post it in the group. I will also provide you the Google form link. Yeah, here. So after posting the assignment, just go through this Google form link and copy your assignment link and paste it here in the Google form, please. So if you are posting your assignment in the Facebook or LinkedIn, in the sense the top left corner there is 3 dot, right? So copy that link and paste it in the Google form. Shall we move to the today's topic? Everyone submit your assignments as soon as possible. So 10th day we have to move for second assignment. It's already day 8 today, right? So try to submit your assignment today itself. So today's topic. So what are we going to learn today is monitoring soil moisturization using ESP8266 and Ask Sensor IOT Cloud. Facebook link is not working, in the sense just try to join in the LinkedIn group. I will check the issue about in Facebook, sorry. So here we will be using a Node MCU ESP8266 Wi-Fi module and a soil moisture sensor that measures the volumetric content of water inside the soil and gives us the moisture level as output, and its measurements will be monitored over the cloud using a user-friendly IoT platform called Ask Sensor. So let's start. Venkateshwaran, I will check the issue and I will update you in tomorrow's class. And coming to soil moisture sensor, it is an electronic device that measures the amount of moisture or water content in the soil. It is an essential tool for farmers, gardeners and landscapers who need to monitor the soil moisture level to ensure that their crops or plants are getting the right amount of water or not. So there are different types of soil moisture sensor available in the market, but most of them work on the principle of measuring the resistance of the soil to an electrical current. When the soil is dry, it has the high resistance. When decreases as the soil becomes moister. So the sensor measures the resistance and converts it into a moisture reading that can be displayed on a screen or transmitted to a data logger or controller. So this sensor can be used for various applications such as precision irrigation, drought monitoring, environmental research and soil analysis. So they can be installed at different depths in the soil depending on the type of crop or plant being grown and the soil type. So some soil moisture sensor can also be connected to an irrigation system or a weather station to automate watering based on real-time soil moisture data. So coming out its pin out, it has a probe and amplifier. So the model name is FC28 soil moisture sensor. It typically has 4 pins labeled as VCC, ground, D0 which is data output and analog output pin. So VCC, this pin is used to supply power to the sensor. It should be connected to a 3.3 volt or 5 volt power source. And coming to ground, this pin is the ground connection for the sensor. It should be connected to the ground of the power source. And coming to digital output pin, This pin is the digital output of the sensor. It is a digital signal that indicates the moisture level of the soil. When the soil moisture level is below a certain threshold, this pin will output a low signal which is 0 volt. So when the soil moisture level is above the threshold, this pin will output a high signal which is 3.3 volt or it can be a 5 volt. And coming to analog output pin, this pin is the analog output of the sensor. It outputs an analog voltage that is proportional to the moisture level of the soil. So the voltage range is typically between 0 volt and the power supply voltage. So by measuring the voltage at this pin, you can get a more precise measurement of the soil moisture level. So coming to the specification of the soil moisture sensor, which is input voltage is 3.3 volt to 5 volt and output voltage is 0 to 4.2 volt and its input current is 35 milliampere. And coming to output signal, it can be both analog and digital. You can use whatever you want. So in this interface, we are going to use analog output. Next, coming to as sensor setup. Let me explain how to create an account and how to use the as sensor account. So for that, first thing you will need to do is create an account for as sensor. So go to Google, search as sensor, log in using your email ID. If you have PC or laptop with you, just try to log in now or just take the notes how to do the login step by step. So very first what we have to do is we have to create a sensor. So a sensor device is a communication channel with unique API keys where as sensor collect and stores users data. So each sensor device provides up to 6 modules and shareable graphs. User can send data stream to each module separately. So from your sensor device workspace, create a new sensor device by clicking a new sensor. For that, first click sensor device. Here new sensor. I have already introduced one module before. So this is. Now we have to do a new one. For that, click new sensor. So here you have to give the name like, I am going to give name like soil moisture sensor. Then coming to description, you can give any, if you want to give any description lesson you can give or else just leave it. Now I am going to give like it detects the soil moisture level. This is what I am going to give in the description box. I will check the issues and I will update you in tomorrow class about the Facebook group. Sorry. And then we have to add modules. So you can add up to 6 modules here. So here we are going to only add 2 modules. I am going to add 2 modules. So we can edit this module name also. So one is for moisture level measurement. Here I am going to give the module name as moisture measurement. In the description box I am going to give like it shows the measurement of the moisture level. It shows the measurement of the moisture level. Just click save changes. Here you will get the name and its corresponding description location. If you want to add this location distance, you can give yes, otherwise you can leave this. So then click save. So now you will get the sensor information, its sensor ID, API key, and when it was created and a description that you have created, it will show here. So it detects the soil moisture level, and here coming to the author name And if you paid for this cloud sensor, then you will get the API key out. So otherwise it will show like it only available for paid users, and the date which we have created and the time, everything and all. So just by clicking edit sensor, you will get options like delete, clear, disable. So delete sensor to delete the sensor definitively. So coming to clear sensor, it is used to delete all the data stream that's stored in this sensor. And coming to disable, here you can disable the sensor, no data will be received on this sensor. And also you can generate API key. If you want to generate a new API key, in the sense you can use this edit sensor and you can generate a new API key. So now click save. Coming to module, now what we are going to do is we are going to add a graph view. For the first one, I am going to click this. So there are 7 types of graphs: line, bar, scatter, gauge, table, binary, digital and map. So for first graph, I am going to give line. In the module name, I am going to change this for moisture level. And the x-axis and y-axis, I am going to give date and the value. And also you can give the minimum and maximum level. Let's go with 0 to 100 and click save. So this is your first graph for moisture level measurement, and another graph is for moisture state. So here I am going to use the binary type. Module 2 name is, I am going to give moisture alert. So in on label and off label, I am going to customize it. Like instead of on, I want to show like soil moisture is okay. So instead of off label, I am going to give like it's need water. So if it has enough water, in the sense it will show like soil moisture is okay. If the soil is dry, in the sense it will show like it need water. So save this. You will get another graph here. Let's move. Sorry. So here I am going to cancel it here. I am only going to show this too. So now we have to add alert. You can also send email to your corresponding email address using this add alert symbol. So click this add alert. I am going to enable the alert for give yes. The type is email, and here it is my email ID, and condition is minimum maximum threshold. Here you can give like 0 to 100. So here is the check interval. If you want to update about your monitoring for every 15 minutes, in the sense you can give 15, 30 according to your need. So here I am going to just give 30 minutes. So every 30 minutes I will receive an email like what is the condition of the measurement and everything and all. So click save. That's it. So this is all about our. Here you will get API key, and in the module you will get the chart. So starting from the left, the export latest data, export recent data that are plotted in the graph to the CSV file. And this is the share graph icon. It generates a shareable URL that you can use to share your graph with your friends and colleague, or embed it into your web application. And coming to edit graph, if you need to modify the graph configuration, in the sense using this you can edit this chart. And coming to open graph icon to view your graph data stream in full screen. So on remove graph, it hides the graph from your sensor device page. But here we can't use this because we have to pay for this to use this configuration. So this is all about add sensor. Now we have to move for the coding part. So after writing the code, upload the code into your corresponding microcontroller. Here we will get an output like soil moisture is okay, or it need if it At last, it will print the message like requesting URL, and it will print the corresponding URL in the serial monitor. 5200 border. So change this and reset your microcontroller. Here it will show message like wait for Wi-Fi, connecting to Wi-Fi. So it is connecting to our Wi-Fi. Let us wait for a few seconds to connect to our Wi-Fi. Okay, so Wi-Fi connected. Here our IP address is printed. So our moisture level is 582, and it will print message like soil moisture level and state was sent to ask sensor. If you open your ask sensor here in the sense, you will get graph like this. So are you able to see here? So soil moisture is okay, and here is your graph. It will updated along with the time and date. So 22 May 1736 here. So if I remove the prop from the soil in the sense, it will show like it need water. Wait for a few seconds. It will update. Last updated was 1737. Need water. So if I place the probe inside the soil in the sense, it will show like soil moisture is okay. If I remove the probe from the soil in the sense, it will show like it need water, and the according and the same graph will be sent to your mail ID also. Let's check if we receive any mail or not. Is it clear? Wait for few minutes. The attendance link will be provided in time, on time. So here, no, not this. Okay, 30 minutes, right? So it will be receiving the mail for every 30 minutes. Okay. So if we place the probe inside the soil in the sense, it will show like soil moisture is okay. So this is our output. Here you will get the graph like this. The last update was 1738. Here you will get the date, and here you will get the minimum and maximum value. Here you will get the alert. So this is all about our output. Is it clear? Do you have any doubts regarding the topic? Is it clear? Everyone, is it clear? Do you have any doubt regarding this? So the image show the data read on the ask sensor graph. We can notice two cases. When the sensor is out of water, the moisture value exceeds the threshold and the alert is set, like shown in the binary graph. So when the sensor is in soil, the moisture level is okay. Now you can open your serial monitor on your Arduino IDE. You can cross check the sensor graph readings and values being printed on your terminal. Like value is 56, right? So go to here, we will get value like the last value is 39, 39, 39. It will update. So you can cross check your Arduino IDE also. Is it clear? Do you have any doubt regarding this? I once again remind, wait. I have already provided you the community link to join the groups, and I have already provided you the Google form sheet. Just go and do your assignments and took a screenshot of your code and paste it in the group, whether it is a Facebook group or LinkedIn group. Just go and post your assignment. I will clear about the Facebook issues in tomorrow's class. I will check once. Please try to post your assignments today itself. It's already 8th day, and on the 10th day you will get your second assignment. So try to post your assignment today itself. After posting your assignment, just copy that link and paste it in a Google form also. So this is all about today's session. So let's catch up at tomorrow's class with another topic. Thank you all. Have a great day.